A concise and professional post-production workflow for FPV drones using the O for Pro video transmission system, especially for 2.5-inch indoor commercial shoots. After testing Premiere Pro, CapCut, and DaVinci Resolve, I found that DaVinci offers by far the best gyro flow plugin integration, the cleanest workflow, the most flexibility, and the strongest color grading and post-production headroom. Alright, let's get straight into it. First, we import the footage shot with the O for Pro, and here are some clips I captured using the Linear 25 while chasing go-karts. After importing the footage, the first step is not color grading, but going straight into the Fusion page. Fusion is DaVinci Resolve's built-in visual effects system, conceptually similar to After Effects. It essentially embeds a full VFX workflow directly inside DaVinci Resolve. The advantage is that everything you do in Fusion, loading gyro flow, adjusting keyframes, or changing frame rate and resolution, happens upstream. None of these operations interfere with color grading, motion blur, or editing in the main DaVinci timeline. There are no conflicts, and performance optimization is excellent. In simple terms, the original footage is processed in Fusion first, then handed back to the rest of DaVinci Resolve. What used to be a two-software pipeline is now fully unified. Next, we need to load the gyro flow plugin, which I've already prepared here. If you're not sure how to install it, you can visit gyroflow.xyz, where the plugin page provides very detailed installation instructions. Alright, let's move on. As a side note, DaVinci Resolve does allow you to load the gyroflow plugin outside of Fusion. You can technically load gyroflow directly from the effects library in the edit page. However, this approach causes many issues, especially with color grading and speed ramping compatibility. So just remember this rule. Always load the gyroflow plugin inside the Fusion page. The plugin itself also has detailed tutorials on the official site, but here I'll just cover the key steps. First, let's talk about how to load the gyro data. Let's start clean by duplicating the clip, sending it into Fusion, and deleting all existing nodes. Alright, I'll walk you through it again step by step. First, we search for the plugin and drag it into the node graph. Since Fusion works directly on the original footage, you can see that the current resolution is exactly what the O for Pro recorded, which is 3840 by 2880. This resolution isn't very friendly for vertical platforms. In practice, we often need vertical videos, standard 16:9 horizontals, or even cinematic aspect ratios. So most of the time, we need to reframe the image. After loading the gyro flow plugin, you'll notice a red warning message. This indicates that the plugin is currently not outputting any result. If we check the inspector panel on the right, we can see the same thing. No project file has been detected yet. At this point, there's no need to open the standalone gyroflow application. You can work entirely inside the plugin. All we need to do is click this first button. You'll immediately see that the data status changes to OK. At the same time, the image shows lens distortion correction and stabilized motion. You can also see below that the project has been successfully loaded. This project is actually generated directly from the MP4 file itself. This is because when the O for Pro is set to wide-angle mode with stabilization turned off, it embeds both gyro data and lens profile information into the file. That's the first and most important step. The second critical step is setting the output resolution. The output resolution here must exactly match the resolution of the video project you plan to export. Let me show you my timeline settings. I'm using a 2160 by 2880 vertical 3:4 resolution. This works very well for vertical platforms. So in the plugin, we must set the output resolution to match the timeline exactly, with no mismatch at all. Once set, everything is correct. However, you'll notice something strange. Even though we've set the output resolution inside the plugin, the Fusion viewer is still showing 3840 by 2880. This causes an odd stretching issue, essentially turning a vertical 3:4 image into a horizontal 4:3 frame. So we need to move on to the next step. We search for resize in the effects library and drag into the next node in the Fusion node chain. This step tells Fusion that the output resolution has changed. We manually set the output resolution to match the plugin's output, in this case 2160 by 2880. Now you'll see that both the output image and the Fusion preview are correct, with no stretching at all. At the same time, the clip in the timeline is now correctly recognized as 2160 by 2880. If we don't enable resize, let me show you what happens. You'll see something very strange. In the edit page, the clip is stretched in the same way as it appears in Fusion. It even crops out content on both sides. You then have to manually enable stretching to make it look normal again. But this stretching is actually incorrect, because Fusion is already outputting the image at the intended resolution. When the clip is stretched again in the edit page, it can cause a loss of image detail. Even though I don't have a strictly scientific test to prove it, theoretically, that quality loss does exist. It's similar to scaling an image up and then compressing it back down again. Even though DaVinci uses high-quality floating point pixel mapping, I still consider this kind of display stretching to be imprecise. At the same time, without resize enabled, we can't properly preview the full frame inside Fusion. This becomes especially problematic when doing keyframe camera moves. In that situation, the preview is clearly unreliable. We simply can't see what we're actually doing. Alright, let's turn the resize adjustment back on. With resize enabled, we no longer need to use stretching. We can simply use the project settings. Once these three critical steps are done, we're ready to start keyframing our camera movements.